How could a mushroom hiding under a log be made of sunlight? How is the shade you enjoy on a woodland hike thanks to the wildflower growing by the trail? Let me guide you through some of the winding pathways that photons traverse through a woodland. Gazing out upon the expanse of nature, you likely are not realizing that your view is filled with manifestations of sunlight. This is most easily observable in trees that take carbon dioxide from the air, combine it with light through photosynthesis, toss aside the useless oxygens, and form wood. But this process can be reversed by introducing enough energy to cause ignition, reverting it back into CO2 and releasing the stored sunlight that we call fire. In short, this solidification of light in the form of trapped carbon means trees grow from the air and are merely anchored to the ground. Trees, like many things in nature, grow in fractals, which research has shown that looking at these natural patterns results in stress reduction, increased brain function, lower levels of irritability, aggression, and violence. Growing in fractals helps maximize the light-gathering potential of trees, especially in a crowded forest. Bottomland trees specifically are able to maximize light gathering by growing out into open areas like rivers. This strategy also allows them to disperse their seeds more successfully via water and the increased winds of a river channel. But what is stopping a tree from growing a few more meters, spreading out its branches and outcompeting its neighbors? You know what the enemies of tall trees are? Windstorms and lightning. Resource availability and local genetics of trees that develop here maintain a height equilibrium within a forest canopy. But a forest is more than the trees. Let's take a look below the canopy to see how light influences life there. The understory is where we typically experience the forest and can get to know the animals, plants, and mushrooms that call it home. Come spring, ephemeral flowers pop up to catch light before it is obscured by the canopy. These short-lived plants capture nutrients during a season when rains would otherwise wash them away. Termed the vernal dam theory, one study showed that captured nutrients can be nearly equal to the annual net losses, making them available later on in the growing season. These plants are an important food source for spring insects such as queen bumblebees, looking to start a new brood. Pollinators like this tend around 70% of flowering plants across the world, and the hard work of these critters accounts for 1 in every 3 bites of food we take. As seasons progress, many other species start becoming more active, such as the beaver. This famous animal lumberjack creates its own preferred habitat by altering light and water flow through an area, helping to promote the growth of its favorite food sources, such as cattails and saplings. Some of these saplings may have popped up due to an animal behavior known as scatter hoarding. Squirrels are very well known for this nut caching behavior, selecting nuts that will fill them up fast during winter, when every calorie counts. And they help spread genetics through a forest by moving seeds up to 500 feet from the parent tree. Cute as these warm-blooded animals may be, they're not the only heat-producing organisms in the forest. Skunk cabbage is an endothermic plant that produces heat in its reproductive organ. Temperatures can be up to 60 degrees Fahrenheit higher than the ambient air temperatures, often making a good stopping point for pollinators to stay warm during freezing nights. Helping each other out, or symbiosis, is a characteristic among many species, such as the trout lily, who will give some of its spring nutrient stores to nearby sugar maple saplings, who reciprocate by giving back nutrients during fall when the lily sends out roots, but no leaf to photosynthesize with. This is made possible by what is often called the wood wide web. It consists of funguses that live in the soil and are in intimate communication with at least 80% of the plants on Earth. They provide nutrients that roots simply can't break down in exchange for sugars produced by light through photosynthesis up in the canopy. Hyphae, the long, fine threads facilitating that, can be so dense that in 1 cubic inch of soil, 8 miles of it can be found. Trees may be connected to hundreds of other trees through this underground network, exchanging water and nutrients to each other and sending warning signals when under threat. They will play favorites, though. Mother trees will specifically help their offspring survive up to 4 times longer in the understory. Lurking in the shadows, though, are non-photosynthetic plants, such as the ghost pipe. This parasitic plant feeds off of mushrooms in the Lactarius and Rosula genuses, previous slide, who transport nutrients for pine, beech, and oak. They are essentially stealing the converted light energy flowing between trees in the silky underground fiber optic network of the mushrooms. Some types of mushrooms consume dead wood, but due to their historically late arrival of 300 million years ago. Oh, where am I? Trees growing in the boggy conditions of the Carboniferous piled up for 60 million years until decomposing bacteria and fungi caught up with this untapped food source. Yes, we have their late arrival to thank for all the coal which powered the world into what it is today. Many creatures, including us, consume the fruiting bodies of mushrooms, and some complete their life cycles intimately intertwined with them, such as this forked fungus beetle couple. Their diet and the diet of their progeny consist of artist conch mushrooms and their relatives. Parasitic mushrooms are often found growing at the base of a tree and cause what is called butt rot. Species of honey fungus are notorious for this practice, mostly because of how largely successful they are at it. Take the humongous fungus out in Oregon that's about the size of 1,665 football fields. That's a lot of butt rot. Ultimately, these trees will crash to the ground. The hole in the canopy is just the opportunity that saplings in the understory have been waiting for, sometimes up to 80 years. Branches shoot upwards in fractal patterns, while thanking the squirrel who planted it there, the trout lily who shared its breakfast, and the mushrooms and fellow trees who nourished it. The phases of life within a forest are diverse. The forces driving it are quiet, but intense. When you look out again into the natural environment, I hope your view will be more illuminated with how the tendrils of sun enter into its natural cycle. And now, you might be able to see the sunlight in a mushroom hiding under a log. Thank you.